Thank you very much for the invitation to give this short overview of our work here at Delft University of Technology. On behalf of the whole team, I present what we have done, where we've been very busy with last year. Basically, our team, or not our team, but we and operators have drilled a geothermal double on the campus to a depth of 2.5 kilometers, where water is around 70 degrees, 75 degrees centigrade in a porous sandstone reservoir. And the aim of that project is twofold. There are partners involved. These are commercial partners that are looking to use the energy in the subsurface for heating up the campus itself and a couple of suburbs around the campus in the city of Delft. So it's really a commercial project but on top of that, there is a large scientific component in there, and that's run and it's only TU Delft that is involved in that. And so it's a combination of both things, both research as well as commercial use of that geothermal duct. And the aim for us as researchers is that this is an infrastructure that we, but also others in our research community, can use for their own scientific research and teaching. So data and sampling, as well as access to the site, is open via the transnational access EPOS-NL, EPOS large calls that are available in the Netherlands. So what we have done, we started 12 years ago already by this idea, and finally, let's say this summer, we started drilling a well really in the center of the campus to a depth of 2.5 kilometers and that's why it's called the Delft Sandstone Reservoir. That's a very porous 20% porous sandstone reservoir, rather thick, that has proven in cities around Delft already to be good enough for geothermal energy. So it's not something that has not been done before in the Netherlands. We started in June by the first drilling our production well with a 800-meter vertical section, and then there's a deviated 45-degree section into the reservoir, and that ended somewhere in the end of August. What we did there, we took lots of cutting samples. We took core material of the Delft sandstone itself and the overburden clay on top of that. And we performed a large suite of wireline logging measurements inside of the borehole to collect as much as possible data on both the reservoir, the underburden, and via wireline logging through casing also of the overburden layers on top of the reservoir. Now, and then that went reasonably well. Then we must say in the injection well, the aim was to really have a very long open hole section over the 800-meter to 2.5 kilometer section. As a completely open hole to do all kinds of coring exercises there, as well as a large logging campaign. The well itself was not stable enough. It needed a number of, let's say, sidetracks, or 2 extra sidetracks to be able to complete the well. So we unfortunately were not able to get logging and coring over that long open hole section. We only were able to do that inside of the reservoir as well. So both producer and injector have now logging data and coring data of the reservoir and some of the underburden material. And if you're going to look here, this is a top view image of the producer in red and the injector in green and purple in the end. And what will happen now is that on site of the campus, the heating network, the heating system will be installed, and then the plan is that in 1.5 years' time, depending a bit on permitting, the commercial parties will start producing the geothermal heat. They will inject cold water or cooler water in the reservoir here. Then the the fluid is supposed to flow towards the producer and produced from there, and then over the next 20 to 30 to 40 years we will be able to heat up our campus with geothermal. If we summarize, and here's maybe an image of the data sets, just the lithology, the stratigraphy that we've recorded. And we talk always about the Delft sandstone, but in reality it's actually an alternation of sandy layers, sandstones, and quite impermeable clay layers in between. And both the sand layers as well as the clay horizons have been sampled by coring, by sidewall coring. Cutting material is available in a very dense set of data set, as well as the logging over the whole suite of sandstone and shale intervals is present. And all that material and data is in due time available via the TNA access. So I've talked about cuttings, corings, open hole logging data, as well as some, but there's much more data to be collected and is collected already right now. Water sampling for maybe water chemistry research. There will be fiber optic cables installed primarily in the producer, pressure and temperature sensing in the producer probably soon. That will be installed for monitoring inside of the borehole while we are producing, and that data will also be available. And in the future, the borehole is available for experiments, for extra monitoring, and so we have made an agreement with the operator that we can every year we can ask them to stop production of heat for a little bit, and then we can do our experiments in that or our measurements, and both of them as possible. Of course, you need to get permission for that, but that is possible as well. Now that's the borehole itself, the doublé, and then there is a monitoring station set up around the borehole. There are 3 seismometer sets of seismometers. These are 200-meter deep borehole, and one of them is even 500-meter deep, where lots of geophones are in there. Fiber optic cables are in some of them for monitoring the seismicity or absence or presence of seismicity over the production lifetime of the well. So that's one thing that's already available. And then, like was just presented, there will also be there's plans available to drill 5 or 6 small 200-300-meter wells in there, where we can do high temperature storage of the excess hot water that we produce in summer. So a geothermal system operates best if you are producing at a constant rate. And so we will probably overproduce in summer, and that overproduced heat is stored in those 200-meter wells around the geothermal doublé for use so that excess heat that will be then used in winter to help heat up the campus. Those boreholes will also be instrumented with probably fiber optics, etc. Planning to start doing that this year. So the data of that and also more will be available very soon. And then a second research project that has been funded is a deep monitoring borehole somewhere in between the injector and producer, probably be drilled in the next 5 years, depending on permitting and design and everything. And it will be a vertical well or almost vertical well to levels that are deeper than the injector and producer. And that will be a monitoring well. And so all kinds of monitoring stations and systems will be placed inside of that borehole. And so it's not a hole that we will use for producing heat. There will be a seismic monitoring in there, fiber optics are planned in there, electromagnetic measurements are planned to, or tools are planned to be in that deep monitoring borehole. And we aim to do, again, large set of continuous coring and logging of the reservoir sections, but probably also deeper sections of the reservoir. I think that's the summary, the 10-minute summary of our multi-scale laboratory, the data that is available, and the opportunity to use that for additional access to the system. So thank you.